What the three concepts in the calculus column have in common is in some way we're looking at a list of values and what they approach. There are always two variables involved, right? And I just said A and B, it doesn't matter, X and Y. But what we're asking is, okay, as this one changes in a certain way, like A here starts at 1.1 and it's getting very, very close to 2. What happens to B? In this case, it looks like B is getting very, very close to 13. Now, we may be talking about a nice polynomial function, x and y, and this may actually end up being 13. Or it might be a scenario where it doesn't ever actually reach 13. But we don't care about that. We want to define what it means for a value to approach a certain value. Okay, so that's what we kind of have to be thinking about today. The limit as x approaches 2 of x squared minus 3x plus 2 over x minus 2. I have picked a function that has a characteristic that it's undefined at a particular x value. These are good examples to use when we're learning about limits because, again, we don't want to talk about what happens at 2. We want to talk about what happens near 2. Finding the limit as x approaches 2 of this function, we can't just plug in 2 and see where it ends up because it actually is undefined there. So instead, you're going to fill in this table of values. All right, so help me out here. What function are we analyzing with this notation? We're analyzing f of x equals x squared minus 3x plus 2 over x minus 2, right? That's inherent in that notation. We're taking the limit of a function. The function happens to be equal to this part. So in this table, when I say the f of x value, I'm talking about the y value that you get when you just plug that x value in. What did you get when you plugged in 1.75? 0.75, and then 0.9, 0.99. So 1.001, 1.01, 1.1, and 1.2. Okay, so where are we headed toward from each direction? From the left, we're headed toward 1. 0.99 is getting very close to 1. From the right, we're headed toward 1 also. And the reason why I made a point of saying from the left and from the right is sometimes you'll be headed towards different values. And in that case, the limit doesn't exist. That is possible. But in this case, from the left, we're headed toward 1, and from the right, we're headed toward 1. So we are going to estimate that this limit is 1. It's as easy as that. You're just looking at trends in the values. Let's think of it as a graph. I'm claiming that, in fact, this function, x squared minus 3x plus 2 over x minus 2, is exactly the same as the function f of x equals x minus 1, except at 2. How did I come to that conclusion?
By expanding the numerator.
That's right, by factoring it out, right? So algebraically, to demonstrate algebraically that the functions are the same, all I mean is factor and cancel common factors. So what we're going to do is we're going to say, okay, f of x started out as x squared minus 3x plus 2 over x minus 2. That's the same as, and I'm going to factor this trinomial, x squared minus 3x plus 2. What multiplies to give me positive 2 but adds up to negative 3? Negative 2, negative 1. Okay? And so we're going to cancel, but you can't actually write equals x minus 1. Why would that be incorrect? Why would it be incorrect to just write equals x minus 1 and just stop? That's right, because if I plug in 2 to x minus 1, what do I get? 1. And that is not what that expression equals at 2. So let's just be clear, they are equal everywhere except whatever would have made that denominator equal 0. So not at x equals 2. All right, so we just demonstrated that in fact those are really the same thing. X minus 1 when x does not equal 2. So with that in mind, what is the graph? This is much easier to think about as a graph, right? What's f of x equals x minus 1 look like? A line, right? It's a line with a y-intercept of negative 1. So we're down here 0, negative 1. Has a slope of 1, so it's going to go through 1, 0. But when we get to 2, instead of drawing a filled in dot, I just draw an open dot. Where would that have been though? 2 comma what? 2, 1, right? X minus 1, 2 minus 1. This is the graph of the function f. Let's think of this limit in a different way. On a graph, when you think of a limit, you're literally just thinking of following the line from the left and the right toward whatever x value we're being asked about. In this case, the limit as x approaches 2. So from this graph, the limit as x approaches 2 of f of x is going to be whatever y value we're headed towards as we head towards the x value 2. So you're imagining these little arrows here. Okay, we're going close to the x value 2. So we're following along here from the left. We say from the left. That's formal language, from the left and from the right. From the left and from the right, we're headed towards this open dot, which happens to have a y value equal to 1, which is the same conclusion we came to before with the table.